So what I was thinking is, why should light have the highest speed in the universe? So the reason I was thinking about this is basically because, like, see, when you look at it from a fundamental perspective, these are like electromagnetic radiation. It's not like particles with mass. So, and the practical aspect of it is, I mean, one is that the mass converts to energy and there's that transaction happening. But if you think about it, it's just like for us to perceive, for living things to be able to see and perceive, right? But what if there were no living things? What if there was nothing living that was there to perceive it? Then why does that? You get what I mean, right? Like, all the contradictions arise from the fact that, okay, first an event has to happen and that information has to reach you, and then all the other things can follow. But that is just for your cognitive processing. But what if we take out that fact like completely away from the argument? There's no life, there's no processing, there's no cognition, there's no perception. Now it's just particles and matter and processes and radiation going away from it. Why does light have to be the fastest thing in the universe?
So one thing I know for sure is, regardless of there's a cognitive being or not, it doesn't matter for the natural processes to occur the way they do. It's the observation that matters. So whether the observation is through the eyes of a human being or through an animal or through an instrument, observation is what changes the regular flow of it. So I was reading up on this quantum experiment, the Young's double slit experiment. So what happens over there is, like, there are some crazy things that happen. That's one of the most favorite experiment of mine ever, because it resulted in some crazy results. So the details of the experiment aside, so what would happen over there is that the wave would collapse into a single particle, into a single point in space. So that happens only when an observation is made. So this happens regardless of whether a human being is there to physically see it. If you try to tamper with it by trying to add colored slit for one of those two slits and a different colored slit for the other slit to see through which slit the particle passed through, it would still be affected. Like, it would just dissolve into one single pattern. That is because you're literally tampering with the particle, because it has to pass through that slit. So regardless of whether someone sees it or not, it doesn't matter. It's affected, so that's what matters for it. So even with your question, I feel
so yeah, maybe we can just put a link in the description or something for the Young's double slit experiment for people who are curious. Yeah, go ahead.
Yeah, so I think even for your question that you're posing, it's pretty much the same regardless of whether there's an intelligent observer or not. It doesn't matter, as long as it's as long as it doesn't interact with anything, it would still follow its natural flow. But if it hits something, it would
no, you kind of contradicted yourself, right? You said that the observation matters, and then you were like, if there's an intelligent observer or not, it doesn't matter. It would still go its natural flow. It's kind of a contradiction, right? If there is an observer and there's an observation, then you are changing the process. That's what the quantum mechanics part of it you were explaining, right?
Yeah. I mean, whether an intelligent observer is there or not, that doesn't matter. Regardless of the observation, it changes its natural flow. Whether it's us or any instrument, it doesn't have to be a living thing or an intelligent being. That's what I meant.
Okay, but that's what. Okay, fine. Let's leave all of that aside. Let's say there's no observation, no instrument, nothing. If you were the one designing this whole, okay, let's say cosmos for now. I know it's a little pushing it, but if you were doing that, what would be the reason or incentive for you to assign light the highest speed? Like, why should something have the largest speed, and why should there be a limit on that speed? It's assuming there's going to be no life in this universe to observe it and to have crazy effects mentally or whatever.
Yeah, I mean, that I have no answer, because even I've pondered a lot about why is there a limit on anything. Because some theory states that, so this brings a bigger question, I feel, where is there something really that is infinite? We currently don't know. Universe is hypothesized to be infinite, but we actually don't know. It's still at best a theory. So now if we accept that there is a limitation, that means there could be limitations to pretty much everything. So how fast an object can travel, that would be the speed of light, and how small a thing can be, that would be the Planck's length. So yeah, maybe there are those limits.
Yeah. But that also actually kind of reminds me of something that I was thinking about, and this is something that I actually thought about kind of by myself, and I mean not in those exact terms, but I just thought about it, and then when I was just reading a little bit, it came across as an actual theory where someone's written a paper on it and stuff. And it was this thing about, like, I've always wondered, like, see, math, there's no limits to it. It kind of, you can just keep adding numbers, you can just keep adding, like, the decimal point can keep shifting. There's no limit. But that doesn't necessarily mean that all of that has physical manifestation as actual objects. So I was thinking about that, like, yeah, the math indicates that the size of the singularity, which is the core of the black hole, the actual remnant of the star, where everything has been squeezed into, and it has like crazy density and infinite density, and it's infinitesimally small. But just because the math indicates that doesn't mean that it will be that way. I mean, what does it even mean to be infinitesimally small? It basically becomes zero, right? So what I was thinking is that all of these things, the math might indicate that it's zero or infinite, or in those extreme directions. But there will always be a physical limit that is kind of limiting that from going to that theoretical math limit. And so I just thought about that there will be some size limit for the smallest possible thing that will limit that singularity from getting smaller. And then I was reading online a little bit, and I came across that there's a theory with the Planck's constant and the Planck itself. I think I'll probably post the paper or link in the description. But that says that probably the singularity would stop at that point. And if it's a black hole that's spinning, it will kind of make that singularity inside the black hole like a ring instead of a tiny point.
Okay.
Because of the massive spin, because it spins like so ridiculously fast, close to the speed of light, that singularity wouldn't be able to be a singularity, but it would become a small ring inside. So what you have now is a black hole, and then a small ring inside the black hole, where at the center there was supposed to be a point, but it's actually a ring. And I mean, I'm just kind of like going off into things, but yeah, it was just like very exciting to kind of understand what might be happening there, just based on a pure thought that I kind of happened to have accidentally.
Yeah. I mean, I totally am with you on that one, that just because we can conceive it in mathematics, it doesn't have to be real in the actual world. And maybe we can we can easily write a length that is smaller than Planck length, but that doesn't mean it actually has to be there. So yeah, I'm definitely with you on that one. And regarding the singularity, yeah, it's very fascinating what happens over there. And that's why I think until the point of singularity, we pretty much have everything set, like our theories work. So Einstein's theory, general relativity breaks only at two places. So one is at the beginning of the Big Bang, like what happened at the time of the Big Bang. I think it holds until t power minus 37 seconds or something like that. And then the other part where it breaks is at the center of a black hole, near the singularity. Those are the only two parts that it breaks. So this has led to a very interesting topic, or an area of science, which is quantum gravity. So that's where, so now everyone's trying to work together a theory which would explain everything. So you have really good working theories for two things. One is the quantum mechanics, which explains everything related to the world of the small, and you have general relativity, the world of the large. So, and those two are like pretty much perfect. But if you can find the link between those two, then yeah, I think probably that could explain singularity. So that's quantum gravity. Yeah, so pretty exciting times.
Yeah, probably. Yeah. Probably 2 other episodes for those.
Yeah, for sure.
But yeah, but you were saying that like the theory, or at least we're good till the singularity part. But I was still kind of trying to understand, like, okay, let's go back to the first question that we kind of tried to start the episode with, right? What is actually inside a black hole besides the singularity? So in all of the videos that somebody might see on YouTube or you and me might have come across, it always seems like that, assuming it's a normal size black hole, that once you start kind of getting in, okay, let's say it's a black hole here, and then I start getting closer and closer, the field of view starts becoming black, like you're getting closer to the black hole, so it kind of starts expanding in your field of view, and then it starts becoming bigger and bigger, and slowly it feels like it's kind of crossed your peripheral vision, and it's starting to expand, like you've started entering the event horizon, and you can see the universe kind of like behind you, getting smaller and smaller in that hole. And I'm pretty sure like you would have seen those simulations and videos too. But I was kind of trying to understand, like, why is that? Because all of these things that are getting into the black hole, there's photons and radiation and everything. So I haven't reached the singularity yet, and assuming that I'm not getting spaghettified yet, I should still be able to see all of those photons and everything inside the black hole. It would be like a crazy party inside the black hole, right? It wouldn't be completely black. The only reason it appears black to me right now, looking from the outside, is because nothing is able to get out. But that doesn't mean nothing is inside. Like, so from what I was just trying to imagine and think, I was just thinking that like things would still kind of be spiraling into the black hole, maybe really fast, maybe really quickly, and I'm not sure what's happening there, obviously. But it's not just completely black like all the simulations show you. It's not that you're just getting to the center and everything around you is just black. I don't know what you'd be able to see. It'll probably drive you crazy, and it wouldn't make a lot of sense because it'll just be a lot of photons and some kind of an image would try to get formed. But I think you would be able to visualize something, like you'd be able to see something. It wouldn't just be complete darkness. That's one thing that I was just trying to think. What do you think about that?
Yeah, that, my friend right over there, leads to a very, very interesting explanation and very interesting stuff that happens in a black hole that I recently figured out. I mean, I didn't figure it out. That would be crazy. That would be crazier than what happens inside a black hole. But yeah,
nice.
Yeah, but yeah, this stuff was like, this was just mind-bogglingly crazy. So until now, what I was thinking was that black holes, yeah, sure, they are the corpse of a star. So that means I was thinking at least they'll be a size of, I don't know, Earth or something, like at least supermassive black holes, which are 66 billion times the size of our sun. When it becomes a black hole and collapses onto itself, it would probably become at least the size of the Earth or something like that. But apparently, black holes, they're actually nothing at all. Like, it's a region in space. Like, it's not an object. And I was listening to Jana Levin. So she's an astrophysicist. And yeah, she was giving a really good explanation for this. So, okay, there are a few things to unpack here. So one is we need to understand that time and space flips near a black hole. So space becomes time-like and time becomes space-like. And I think the mathematics of it is not that complicated. It's basically the Schwarzschild equation, and it has a term for distance, which is basically the space term, and it has a term for time, which is the time term. And you can see that when near a black hole, those two signs, they basically flip. So, and you can see that mathematically it behaves, space and time flips mathematically, but this also happens in reality. So Jana Levin, an astrophysicist, so she was giving some example to help us visualize. It still is a complicated example, but it might serve as some guide. Okay, so imagine you're standing in front of a person and you say that this is your right. And they'll of course know that that's right from your perspective, and that if they turn 180 degrees, your right and their right will align. So just like that, when you're going towards black hole, you are traversing through space-time. And now what happens is, it's basically like you're turning yourself through space-time, and some of what you call as space will become some of what your friend calls as time, and your friend meaning an observer outside the effects of black hole. So that's how it sort of flips. For more detailed explanation on that, like for people who are interested, I suggest you check out Sir Roger Penrose's paper, which he released in 1965, I think. Maybe I can link that down in the description. So he actually writes a diagram showing how space and time actually flips near a black hole. And this leads to an extremely interesting consequence. And that's basically that the singularity, the center of a black hole, what was a point in space, it actually becomes an event in time. So after you cross the event horizon, you can be sure that you're pretty much dead. Your life is over and your future is set, and it is as inevitable as death. So taking a step back and thinking about it, black holes are not actually things, like it's actually events waiting to happen. I mean, it's already happening, and when you get closer, that's what's going to happen. They are basically events. So because we know that towards the end of the universe, like pretty much black holes will swallow pretty much everything, and we'll all probably end up over there. So it's just interesting to think that there are these black holes in space and supermassive black holes, just events waiting to happen. So that was pretty interesting for me when I read about it.
Yeah, sounds pretty crazy. I'm still kind of thinking about what you said. I'm probably going to want to check out that paper, but super interesting. So when it flips from a point in space to an event in time, okay, something is kind of trying to form in my head right now, but okay, cool. I will think about it. Oh, dude, careful.
Yeah. But so theoretically, you can access time inside a black hole like you would access space over here. So if you want to access space over here, you just move left, right, up, down, front and back. In black hole, to access past and the future, you can actually move around inside the black hole to access that. But that really, theoretically, it's possible, but you actually cannot move back, because once you enter the event horizon, there's no turning back. No matter what direction you take, it actually accelerates your motion towards the center of the black hole. So yeah, you're better off just not resisting it, basically.
Okay.
Yeah. Another interesting thing was that the original star, right? Like, because black holes are remnants of the star that was once there. The original matter and the mass of the star is still there, but the original matter is actually gone. So after you enter event horizon, there's actually nothing there. So even the light that you were mentioning, like, it can't be nothing, like it can't be black, because only when you're outside the black hole, the light doesn't come out, because it makes sense. Nothing can come out of the event horizon. But once you go inside black hole, it should be there, but it actually isn't. Only in the photon sphere you can see, like, photon sphere is the part where light just orbits around the black hole, and it's still, even that is unstable. So technically, if you just turn towards your right or left, you can see the back of your own head, because the light traveling from the back of the head will orbit around the black hole and hit your own eyes.
You mean like the sphere that's outside of the event horizon, just outside of the event horizon?
Yeah. That's the photon sphere.
Yeah.
So once you enter event horizon, right, there's literally nothing that can just stay over there. Everything has to be going inside the black hole. So nothing can enter your eyes over there. So it will still be dark.
Yeah, but like everything that entered at a certain speed and in a certain direction, right? So wouldn't it spiral into the center? It wouldn't just suddenly be pulled into it will have some centrifugal force, and like the velocity will continue. Do you get what I mean to say?
Yeah.
Like the accretion disk is spinning and then things are entering the black hole. So it can't just like suddenly enter and then just be pulled in directly there.
So you mean to say that it won't go in a straight line to the center?
Exactly.
But rather it would just slowly spiral into
the center. Not slowly. Maybe it'll be super fast. We don't know, depending on the mass and other things and stuff, whatever. But like there'll be some curvature. It won't be like a straight line and you just point. And since other photons would continue doing this at like all the time, you wouldn't just not see anything. It would pass your eye. Do you get what I mean? Like, do you know that simulation? Maybe you can play that in the video. The simulation of how if you suddenly from Earth started moving at the speed of light and moved towards the sun. it wouldn't suddenly just all become big and you wouldn't zoom past it. For a few seconds, your vision would kind of expand because all the light from the background would, like behind you,
enter.
It would suddenly come into the field of vision. Like the light rays would be coming here and then you would be moving and it would enter your eye. So something similar is what I was thinking.
I still think it probably goes in a straight line because after event horizon, right? Like black hole bends space-time in a way that it becomes a well. So regardless of which direction you enter black hole from, so it's sort of this well.
Yeah, but that is just kind of to explain it, right? It's not really a well. It's 3D and not 2D. Like, do you get what I mean? That's just to explain it to people what's actually happening.
Okay.
Even that way, even the sun is a well only. It's just that it's not that deep, but still things spin around it. Like, do you get what I mean?
Okay. Yeah. No, I get what you mean, but I still think like because how dense the black hole is and how much it distorts the gravity.
I mean,
it could.
I'm pretty sure there's a reason.
I'm not sure.
And maybe it's right. Yeah, even I'm not sure, but I think there must be a reason. Otherwise, they wouldn't have like kind of pictured it that way. But this is interesting to think about.
Yeah. And so basically, because nothing can exist like between the event horizon and the black hole because of such strong gravity that everything has to fall into center. Pretty much all the matter that was once the star before and everything that is coming from outside the black hole, right? It all goes in and it's concentrated in such small tiny space which we call as singularity, and there's actually nothing around it. So people like astrophysicists, they kind of consider this black hole as also a fundamental particle because we don't know where the matter goes. Current theory states that okay, it all crunches down and becomes a point like singularity, but that's where quantum gravity is coming in and trying to explain what actually happens, what the singularity actually is. But yeah, some of them is they're also considering the possibility that it could be a fundamental particle that it forms. So it's pretty interesting.
That's interesting. Yeah. But that also kind of, the one famous theory that like a lot of people would probably know is the wormhole theory, right? The fact that they think that the matter that is being sucked in might be being ejected from the opposite of a black hole in another universe, which is a wormhole, which is radiating out that matter and energy in some other space. So yeah, that's also pretty interesting. And if you recall, like a few minutes back, I was telling you about the singularity becoming a ring because of the speed, right? Yeah. So I was also reading this one theory which said that it's possible. See, because the ring would be spinning at such velocity, it would generate an immense centrifugal force. Okay. And in general, anything which has a strong centrifugal force becomes anti-gravity. It's not gravitational. It pushes away things instead of pulls. So what you will have is this black hole, which because of its gravity is sucking in so much matter. And on the inside, the singularity being a small ring, which is spinning so fast with its centrifugal force that it's pushing out stuff. Or in other words, it's kind of like, it's creating a boundary or this inner horizon. And basically it kind of becomes like a wall of radiation, of like really energetic radiation. So you have the outer shell, the event horizon, and then you have an inner ring. So that kind of, takes care of all the contradictions of things being infinitely dense, infinitely squished. All of that is taken care of. And again, that information is not lost. It's still within the black hole between those two horizons. The outer horizon, the event horizon, and the inner ring horizon. So, I'm sure there's some science behind it. There's a paper to back it up and stuff. But it is theoretical, of course. But I was just thinking it's pretty interesting how some of these concepts that we can observe in our everyday life kind of explains that possibility of what it can happen.
Yeah. And so based on what you're saying, I can think of like a 3-dimensional donut type thing inside a black hole where all the matter will be present and nothing can enter that spinning thing and can't get off the event horizon too. Yeah, that's pretty interesting. And even the wormhole theory, right? Like I was so excited about it. I so badly want it to be true that you get inside a black hole and you come out of another one. But it's just that I feel there's one big flaw in it. which is that black hole is something that sucks in matter. So sure, you can probably enter into a black hole, like you'll get sucked in for sure, but there's no exiting from a black hole. A black hole is not known to spew out matter. So you can probably enter, but you cannot exit. So that's where I feel, at least according to just my own crazy hypothesis, white holes might come into picture. So these are just theoretical objects. They are not proved. They're just hypothesized. That's not been observed yet, at least. So I'm thinking maybe whatever gets inside a black hole is probably spewed out from a white hole, if it even exists. That'll be pretty interesting.
I don't know. I'm a bit torn on this topic. Yeah, I mean, no point venturing a guess, but I kind of lean away from the white hole thing. I feel there is a proper explanation over there that doesn't involve other universes and other spaces and stuff. But anyways, that's just me. But like even talking about how things have to be conserved and how it isn't just completely a black hole, right? Like for example, it kind of takes me to the Stephen Hawking hypothesis, and which got proved and later observed, which was that there is radiation coming out of the black hole, not out of, but from the surface. There is quantum fluctuations happening on the surface, and then pairs of particles are being created, with one being sucked into the black hole and one being radiated out completely. Yeah, and that kind of comes across as thermal radiation, which is why we can see X-rays and other things being emitted from that accretion disk. And yeah, so I mean that was named after him, after his theory and after his name, Hawking radiation. I'm sure you're aware of it, right?
Yep.
Yeah, so pretty crazy. And recently I was watching like this one show also, and it's just like this lady kind of gets up in space in one of the episodes. There's a process and there's a story going on, but she basically kind of devises an object to get up in space to check something out about the planet. And while she's just observing the surrounding space from one direction, the computer, like on a screen, kind of starts beeping and says, danger, Hawking radiation detected. And she realized that close by there's a black hole.
Oh, damn.
Yeah, so it's pretty cool. Like, yeah, I know, it's just like so futuristic. It was the one that I was telling you about. I think it's called Lost in Space. So it is a series, and there's 3 seasons, and so it's pretty interesting. You should check it out if you're into space. If anybody is, just go for it. It's really nice.
Yeah, for sure.
Yeah.
So yeah, this actually brings me to how we detect black holes. So initially, now we know that we have Event Horizon Space Telescope, which took the image of a black hole, and yeah, probably we can put that on the screen. But before that, they actually used to measure the gravitational waves that the black holes produce, maybe through collisions with other black holes. I think, 2 spinning black holes colliding. That's what they detected in LIGO. So, and this actually is pretty interesting because it's a new way of measurement. So pretty much every measurement that we made, like in space, was electromagnetic spectrum based. So is it either visible light, X-rays, gamma rays, radio waves, all those. But this is an entirely new way of measuring it. Actually, there is another way called neutrino astronomy. It's again very exquisite field, and they measure Cherenkov radiation and all that stuff. But yeah, apart from that, this was the bulk of measurement using the light. But detecting gravitational waves is another whole new way of measuring it. And they literally have to measure the stretching and squeezing of space-time itself. And it was pretty neat how they built LIGO, which is the gravitational wave detector. So they have this 2 perpendicular arms which are like 45 kilometers in length, and they just shoot a light beam from one arm. It will go hit the detector and comes back, and they do that with both the arms. So if there's a gravitational wave, it stretches and squeezes the space-time, right? So one arm would be stretched and the other arm would be squeezed. So light travels faster in the arm that is squeezed because it has to travel less distance, and it takes more time to travel in the arm which is stretched because it has to travel more distance. So they measure that tiny fluctuation in space-time, and then they detect gravitational waves. So it's like extremely interesting how they measure that.
Yeah. I was watching that too when it happened and it got announced, and it was really fascinating. Like, to think of an experiment that does that is pretty cool, and yeah, hats
Yeah.
off to the people.
And did you know that, like, just yesterday I got to know that they're trying to build a gravitational wave detector which is the size of our galaxy.
Damn. Okay, I don't know about
Yeah.
this one.
It's ridiculous, and of course they cannot build a structure that's the size of a galaxy, so they're doing a pretty nifty thing, just like how they did in Event Horizon Space Telescope. They're using
Dolphin. Okay.
pulsars. Yeah,
Oh.
they're
Okay.
using
Okay.
pulsars as clocking mechanism, and they're measuring those pulsar pulses, and using that to measure gravitational waves. It's just cutting edge technology.
Dang. That's pretty cool. I think what I wanted to kind of like touch on towards the end now is that, I was just kind of like looking into some of this stuff about, like, I'm going to explain a little bit about, what a Dyson sphere is, right?
Yeah.
Okay, I'm just going to quickly give a small explanation. So, guys, like, there's different types of civilization, and, we would be at the next level of civilization if we could harvest the entire energy of our star and perhaps other stars. And what is thought out to be the way to do that is to build a kind of a structure around a star. Maybe if this was your star, you would build a structure around it, like a sphere, maybe like a metallic sphere or a glass sphere or something like that, which basically absorbs that radiation, converts it to energy, and you can use that to travel across space-time. And so that would kind of mean you've transcended your own planetary restrictions, your own solar system restrictions, and you're able to harvest the complete energy of a star. And that sphere, what you build around the star, is called a Dyson sphere. And it need not be one big, huge metallic structure. You can place different mirrors at different places and kind of connect them and make a structure as well, so that it's easier to build, it's not so susceptible, and all of those things. So, yeah, but like, I was just thinking about whether, if you build a Dyson sphere around a black hole, like if civilization were to progress to such a level, if we could build a Dyson sphere around a black hole and try to harvest energy from that or use that, or I think I also saw some kind of a video where they would kind of explain where you can kind of try to use the energy of a black hole by, there's a larger sphere surrounding the black hole, at least like a virtual one that we call the ergosphere. You guys can check that out. We won't be explaining that over here, but basically you can put in some radiation over there, allow it to use the energy of the black hole to gain energy, and then try to use that and harvest it. So all of these things kind of just make me think, what the future holds. So far we've just been able to theorize it, and now we kind of just on the verge, and we've just discovered and imaged it and that stuff in the last 100 years. But like what the future holds for us, and like I was talking about in the beginning of the episode also, about how we might have to live by a black hole towards the end of the universe if it happens, because all of the stars will die out, and some of them will become red dwarfs and brown dwarfs and white dwarfs, and even they will die out and finally kind of fade away and become black masses. And the only thing that will still kind of keep spinning and still have energy and be alive would be the black holes, and possibly any human civilizations left or any other living beings would kind of be settled around a black hole and be harvesting the energy from that. So yeah, it's interesting to kind of think about, what the future might hold with respect to these giant stellar destructive suckers.
Yeah, that's completely true. I think that would make us a type 4 civilization on a Kardashev scale if we can harvest the energy of a black hole. And I'd like to think that we are taking the baby step towards it with our tiny space exploration to moon and making bases on the moon and traveling to Mars. So this probably is the start of it. Maybe one day we will, construct the Dyson sphere, or
or maybe somebody already has. Actually, like, I don't know if this, I kind of just thought about it, or it was, I don't know if it was mentioned somewhere, or if I just thought about it because I was just like spending some time kind of like brainstorming a bit. But like, you're aware of dark matter, right? Or Yeah, dark matter, I think. So because this, like the galaxy and the distribution of things seems to be indicating that there's much more mass in the galaxy than there should be. So we think that there's some hidden matter, or we're not able to detect everything, which is giving it that extra mass so that things are spinning in the orbits that they are spinning in. And I was just thinking, like, what if some other civilization has already built a lot of those Dyson spheres, which is why we can't see those stars, which are actually adding the matter and which are actually that dark matter.
Yeah.
Crazy, right? I don't know. It's like fantasy fiction or...
I mean, they definitely were tinkering with that idea too. Like, what if it's actually regular matter, but we are just not able to see it?
Yeah, but this is like some different.
I mean, because 95% of it, I think 95% of it is filled with dark matter, and just 5% of observable universe is regular matter. It's pretty crazy to think. Everyone wants it to be a new type of particle, or the stowaway of some parallel dimension that's seeping into our universe. But yeah, let's see. It's actually dark gravity, because we don't know if it's even matter. We can only measure the effects of gravity from it. So yeah.
Right. Yeah, I think that brings us to the end of this discussion. And I think we covered a lot of stuff. And just a small disclaimer, we might be a little off here and there, and we might not understand some stuff completely. This is just based on Suraj and my experience of learning through the years, and some of it in the last couple of days, kind of just going back to it a little bit and trying to brainstorm a little bit and just see what we understand, what we want to talk about. So hopefully this has been an interesting discussion, fascinated you. Feel free to check out some of the links on our YouTube. And if you have any questions, or if you want to discuss something, feel free to leave us a comment or messages on Instagram. If you're listening to us on any of the other audio channels, like Google Podcasts, Apple Podcasts, Spotify, you can reach us on Instagram at Curiosphere, and you can check out our YouTube channel as well. So yeah, thanks for tuning in, and have a good one.